It's basically plastic. So it's an insulating material made of polyurethane, which is kind of plastic. It's kind of a wide catch-all, chemical. Generally, it's packaged as liquids, and then when installed, a chemical reaction causes it to expand in place after it's sprayed. So it can expand into cavities and be useful in that way.
Welcome to Building Well, Sustainable Homes, Equitable Communities, your new podcast from New Ecology. Join us as we explore real-life stories from key players in green building and community development. We'll examine exciting new innovations, highlighting practical solutions for creating more affordable, healthier, more resilient, equitable communities. We're building well together.
This episode was made possible by the Mass Save Community Education Grant.
Welcome to the Building Well podcast. I'm your host, Alina Michaelevich, and this is my co-host, Michelle Moran.
Hello.
Today we have Kevin Collins, project manager at New Ecology, here to talk about spray foam insulation. Now, I have to thank Kevin for agreeing to come on this episode without a chance to prepare answers to all my many thousands of questions about spray foam insulation. I have thoughts, I have concerns, so without further ado, let's get into it on spray foam insulation. So welcome, Kevin.
Thank you. Great to be here.
Tell us a little bit about yourself and what you do at New Ecology.
Sure. I'm a project manager here at New Ecology. I've been here for about 3 years. And professionally, I do project management of green certifications such as Passive House, LEED, Enterprise Green Communities, Energy Star, and a few others, as well as provide technical support for energy code and municipal sustainability requirements. Work on these projects from design through building completion. I do some building inspections on behalf of LEED, and then we also provide some technical consulting as part of other company offerings.
Cool. How does spray foam insulation play into these projects? Like, how's it related?
Sure. Yeah. So I will say as a disclaimer, I'm by no means an expert in spray foam, but I used to install it when I worked as a contractor, and I know a decent deal about it from current work. But if there's any comments as a result of this podcast, I would definitely love to hear them and learn more. Spray foam is in many, if not most, of our projects. It's much more common in rehabilitation projects due to limiting conditions that can't be designed around. You're inheriting a building with sometimes unique features, and you have to make these spaces do many things at the same time. Control for water and moisture, thermal performance, comfort, sound, etc. But we do see spray foam in new construction similarly for some tricky details.
Cool. What are the other kinds of insulation other than spray foam, and also what kinds of spray foam insulation are there?
Sure. Yeah. So there's a lot of different varieties of insulation. I think you can go back hundreds of years and see that people were trying to fill the cavities of their walls with any kind of materials they could. Think of log cabins and stuffing mud between them, between the logs. You can go back somewhere within the last 100 years and find people putting ripped up blue jeans, newspapers in walls. So we've always been trying to find things to make our houses warmer. So presently, spray foam is one of many materials. We typically see foam materials such as spray foam or a rigid foam material, cellulose, which is actually a recycled newspaper, fiberglass, which is kind of like a spun glass, as the name implies. And then we also see mineral wool, which is similar to fiberglass.
So not much seaweed insulation around anymore.
I don't see it personally. Maybe there's some product offerings out there, but if it works, it works.
Could you talk a little bit about like open cell spray foam versus closed cell? What does that mean?
Sure, yeah. So I guess there are probably many different varieties of spray foam, and to keep it high level, as you say, there's open cell and closed cell. So the main drivers you'll hear in the industry relate to R value and cost. Closed cell has a higher R value or insulating value per inch, but it costs more, whereas open cell is kind of the opposite. It has a lower insulating value per inch, but it's less expensive. So if you're designing a building assembly and you're limited on space, it might kind of be a costing analysis to which one you use. What is not considered enough and can lead to problems is the vapor permeance of each product. Water vapor can move through materials, and that makes sense, right, when we think of something like fiberglass, which you can poke a finger through. We've all seen a fiberglass bat. So certainly water, moisture, vapor, those can also move through a material. With foam, it's not so easy. You might be able to break through it if you poke it hard enough, but in its cured state, it's obviously much more rigid, and moisture, especially vapor, can have a tough time getting through that as well. So why does this matter? Open cell is more vapor open, and closed cell foam is more vapor closed, meaning vapor can't travel through closed cell foam as well. So when you think of other things that are vapor closed or maybe even waterproof, like metal or rubber or plastic, now think of a wall, any exterior wall, for example, in your house. If you wrap the outside of your house in a big yellow rubber rain jacket, and you said, this is great, my house is going to stay dry, but we need to be warm as well. And then you sprayed a foam on the inside of your walls. Between these two layers are things like your wood framing, maybe your plywood sheathing. So on rainy days, you might still find some water in your rain jacket, especially if it's really nasty outside and windy. You have that wind driven rain, or we're getting a nor'easter up here. So in a wall house example, if water came into this wall design and got the wood wet, it's going to be very hard for it to dry out because you aren't able to unzip that rain jacket. And you toss your shirt or wood framing in the dryer. So imagine in that situation relying on your own body heat and any like convective air movement you can find to dry out your wet shirt inside a rain jacket. That'd be really uncomfortable and kind of take a long time and be hard to do.
Yeah. Wow, what a good analogy.
Yeah, it's great. I've definitely been hiking in a sweater and a rain jacket, and the sweat, gets in the sweater. You can cut that out.
That's accurate because our bodies also generate moisture much like they do when we're in a house.
Yeah.
And that moisture moves around the house. So moisture that we create just through living, through breathing, and through things like taking showers, we need to control for. And so when you have vapor closed products, you got to be cognizant of how they behave and also accommodate some of these behavioral differences through maybe some other means.
Okay. So what is it made of exactly? Is it plastic?
It's basically plastic. So it's an insulating material made of polyurethane, which is kind of plastic. It's kind of a wide catch-all, I guess, chemical. Generally, it's packaged as liquids, and then when installed, a chemical reaction causes it to expand in place after it's sprayed. So it can expand into cavities and be useful in that way.
Interesting.
Is it the same foam that we use for air sealing?
Yeah, definitely. Yep. So I think there's a lot of different ways you can prepare kind of the chemical formula to enhance certain traits. For air sealing, it is a foam. It's more rapidly expanding maybe. And I think that is usually open cell.
Interesting.
And just quickly, could you tell our listeners what air sealing is?
Sure, yeah. So air sealing is finding the cracks and crevices that are inherent in every home. When you think about joining two materials together, like two pieces of plywood, it's not going to be a perfect seal. And so you'd want to, in most cases, seal that up, account for any leakage that you can. And you can do that in many ways. You can do it with caulking. You can do it with a mastic. Spray foam is one way that we will treat air sealing in certain situations.
So my house has a rain jacket because it has shingles and it has siding, right? Where should it have a sweater? Everywhere?
Yeah, definitely in the wall cavities. Yeah, that's probably the best place to put your sweater material.
What about a hat?
Yeah. So these are great questions, and it can be tough to kind of give prescriptive solutions across the board without seeing like each unique situation. But generally, if you think of a lot of the housing stock, certainly in the Northeast and probably much of the country, we have wood frame construction, and then we have an attic. So that's not always typical, but a lot of times we have an attic. So you will want to insulate if you have an existing house that needs insulation in the walls, in the cavities between those wood studs, so behind your drywall or your plaster. And then in the attic, the best case scenario is on the attic floor. There are other options. You can insulate up along the eaves. It gets a little tricky. There are a few things you want to be very careful of up there when you're doing something like that. But if you're just looking to really add some insulating value to your house and save some money on your bills, that would be the easiest, most straightforward way.
Not to go like super in the weeds, right?
Yeah.
But the difference between those two processes you just described. So if you insulate the attic floor, that means that that's like the top of your house, right? But if you insulate up to the eaves of the roof, then your attic's in your house thermally, right?
That's exactly right. Yep. So you're changing the thermal boundary of your house. So when you insulate, you're kind of helping to define what that thermal boundary is. It's going to, in most cases, inherently be your exterior walls, unless you have some kind of 3-season porch. And that's kind of an open question sometimes. But for your attic, that's exactly right.
Interesting.
Yeah.
I believe what Mass Save recommends for their general 1 to 4 family homes is cellulose blown and cellulose insulation with air sealing, and they do the attic floor most of the time. I don't believe they do the eaves and the roof.
And that's I think what I would recommend as well.
And that's if you're not using the attic space for anything, right?
Yeah, I think if you want to incorporate the attic space into like your conditioned envelope, you should really do some careful planning. We can get into the specifics of why it matters, but when you're insulating the roof decking to your house, you want to be careful about, again, to the rain jacket analogy, materials being able to dry properly. And because foam is not super vapor open, just generally speaking, you want to make sure that you're not providing kind of a resting place for moisture behind it where it can accumulate and then potentially build up and eat away at some of these organic wood materials that are in our house.
Okay.
Yep.
So I think that kind of ties into this article that I saw on Guardian.
Ooh, yeah.
You have seen the article.
Yeah, the Guardian one.
Yeah. An article in the Guardian called "They Encouraged Us to Insulate Our Home. Now It's Unmortgageable." And I think they're talking about exactly what you were just saying, right? That the timber, there was concern by the insurance company that the timbers would get eaten away by moisture because there's spray foam insulation on it.
Yeah. So I did have a chance to read the article, and I pulled out a couple quotes, and I think that's exactly right. So one that really stuck out was at the root of the problem are cowboy traders, which I love that. I love that visualization, who apply the foam without a full survey or appropriate expertise, but because of lenders' caution. This is affecting other homeowners who had similar work. So I think there's two things going on. One, maybe folks who are not experienced or not certified to install the product.
Okay.
And then the mortgage industry also being very risk averse, which is totally understandable from their point of view. For me, the article's focus sounds like folks tried to proceed in good faith and essentially perform the work themselves, maybe, or with people that they know, or maybe folks, like I said, who are not necessarily certified or experienced. And that may have been done without potentially a comprehensive plan or evaluation of the existing conditions. Maybe they didn't have enough information at hand or were not aware of how building dynamics come into play. Mm-hmm. So, from what the article makes it sound like, some of the messaging from maybe the government was a little strong in pushing people in that direction. So it may not be their fault that they didn't understand or have all the information they needed to make the right decision there.
I should clarify before we continue. This is in the UK, but the science applies everywhere.
Yeah, I would agree. Another quote that kind of stuck out to me as particularly alarming was spray gunning it into walls.
Sounds like something cowboys do.
It does sound like something cowboys do.
Yeah, it sounds like the UK has a cowboy problem, maybe. So I wouldn't really recommend spray gunning a polyurethane product into a wall without seeing what the conditions are like in there for a number of reasons. You may already have a rot problem going on. So think about what we've been saying about the vapor and moisture properties of foam. You don't want to make that condition worse by putting in a material that can't dry out very well or inhibits other materials' ability to dry out. The other part of the article mentions open cell foam. So there's different dynamics from closed cell. It's not impermeable to moisture and vapor, but also doesn't allow easy drying. I think generally speaking, even I hesitate a little bit to blow something like cellulose into walls sight unseen, just through little holes. It's work that I did a lot myself, and I have had it done on my own house, and I feel fine about it because we understand the properties of cellulose. It can really kind of allow moisture to move through it and dry out much more easily and disperse. Foam does not do that. So if you're blowing it into a wall cavity sight unseen, it could be a recipe for something bad.
Interesting. Yeah. Okay. So in the UK, we're talking about these cowboy installers, right? So how do you know if your installer is good? Like, should you ask them certain questions? Like, how do you get at that?
Certainly. Yeah. And I think this is kind of a great rule of thumb for any kind of work you're going to do on your house, right? You want to check your sources. You want to make sure that they're experienced, that they've done this work before. There are certification programs for spray foam installers here. I'm not sure about the UK, but certainly in the US, there's a certification program. The other thing that is slightly different maybe to where we are here with the Mass Save program compared to the UK is that the Mass Save program inspects the installations of their jobs that they help fund. And also you need to be registered with Mass Save as a contractor. So they do a lot of that vetting for you. As opposed to in the UK, the article mentions that there were hundreds of thousands of homes that may have been affected, but the quote is that some of which may have been funded by the government. So that again brings me back to the messaging may have been there that this is a good thing to do for your home, but I'm not sure what level of participation officially there was from the government in kind of paying for that.
Yeah. Okay. So the Mass Save program should give people peace of mind.
Certainly. Yeah. Absolutely.
That's awesome. Great. Okay. Well, that's a good segue. I have a lot of questions.
Great.
So So we did a home energy assessment, and unfortunately we have not been tube wiring, so we weren't able to do some of the follow-up from that yet. But in the meantime, I was interested to see if we could do any insulation to make our home more comfortable in the winter.
Yep.
So separately, we had a vendor come to look at the insulation potential at our house, and they came back with a quote related to spray foam insulation. So that's where some of my questions come from.
Let's hear them.
I read, as a layman who knows nothing about this, that they can off gas in really dangerous ways.
Sure.
And it sounded like that only happens if the insulation is poor. But can you tell me about that?
Sure. Yeah. I think that's a valid concern, certainly. A lot of materials that we have in our homes can off gas. They have VOCs, volatile organic compounds. Spray foam is no different than that. And each type or variety can maybe have a different level of VOCs. So VOC content is something that we want to be very cognizant of. It's in our paints, it's in finished materials like carpets, it's even in cleaning products that we use in our house. So as long as we can install them properly and account for this off-gassing process, then it should be okay. We learn to live with a lot of these risks and redirect the effects of them. So I think it's just a matter, as you say, of making sure the installer knows what they're doing, because there is an inherent strategy or correct way to blend the insulation. So you make sure that it's kind of mixing properly.
Okay. So because these installers are certified, they should know how to do that properly and have it be properly mixed and all that.
Yeah, absolutely. Yep.
Okay, great. Okay, my next concern is that this could be the next asbestos vermiculite lead paint situation, right? It's only been around for maybe a little while. So it hasn't been 30 years and people are trying to remove it from their house potentially. Is there a concern there, I guess?
Yeah, so that's actually a great segue to what we were talking about just now about managing living with VOCs. So things like asbestos, vermiculite, lead paint, we live with these things now, right? So you can walk down the street and see homes with asbestos siding that's still in place. Lead paint, we often encapsulate because it's safer to kind of control it rather than try and scrape it out and get it in the air and get it moving about. You also have to think about these materials when we're trying to remediate them. You sometimes have to be very aggressive in how you remove them, and then you're moving them somewhere else. So that can sometimes create additional risk with getting it into the atmosphere, getting it into the environment, affecting other people along the way. So sometimes the safest thing to do is to just kind of treat it properly in place. And so I think catastrophe might be a little bit alarming. But in terms of spray foam, we do need to be concerned about it because VOCs are carcinogenic, as we know, but it's in a lot of things. So we need to be cognizant of our exposure to VOCs and especially how we treat ventilation in buildings. I think another thing that is not spoken about enough, which is a totally different topic, is radon. That's something that's naturally occurring, which just comes up from the ground in our homes, and they're not really built to deal with it. So yeah, we fight a lot of fronts.
Yeah. I have this old roommate of mine who listens to this podcast who said that I frequently sound very suspicious.
I think that's a good quality.
And so this episode basically is me being very suspicious because spray foam insulation is something that people are just so excited about that I'm just people are too excited about this. It's suspicious in a way that people were so excited about asbestos. People were so excited about how great lead was at maintaining pigments and paint.
Yeah.
I'm just it's suspicious.
Sure.
Is it suspicious? Should I be suspicious?
I think your suspicions, I think your intuition is right. That's a great quality. I think spray foam has its uses, and I think we need to be aware that, to your point, that maybe lead or vermiculite were not save all, the silver bullet kind of technologies. We shouldn't spray foam the planet by any means. It should be used in really well-defined and succinct strategies. So let's take a few real-world examples, right? So think about a detached single-family home. You may see spray foam around the top of the foundation walls and the rim joist cavities or along the bandsill. You might see it in your attic along the top plates of your interior walls. You might even see it along the underside of the roof sheathing, which, as we said, is kind of a different situation. You might even see it inside your walls and not be aware of it unless you do some DIY work. In commercial buildings, we may see it in areas that require high R value in smaller spaces, or in areas where we're concerned about vapor and moisture control due to various dynamics pertaining to temperature gradients, vapor drive, dew point, a lot of tricky stuff like that. But it should be in defined areas where we're dealing with a lot of things at once. So the benefits of spray foam is that it has high R value, like we mentioned, and it has those particular vapor qualities. But you can still get high R value through other insulation materials, and you can control vapor by pairing them with something else, like a vapor control layer. Reasons why you may not want to use spray foam is the environmental impact that it can pose. So it has a high embodied carbon compared to other insulating products. It also has blowing agents in it, which, as we know, blowing agents contain aerosols and that can have greenhouse gas potential. So there are plenty of reasons not to use it. I would certainly advocate to use other insulating products, specifically wood fiber insulation, cellulose, fiberglass, in that order. And then use spray foam when you need to use it in some of these tricky spots.
Okay, interesting.
Hey there, homeowners. Are you thinking about renovating or adding to your home? Want to make those upgrades not only stylish, but also energy efficient? I'm Molly with your Mass Save Minutes, and you're in the right place. Mass Save is offering amazing programs to help you make your home more comfortable, energy efficient, and budget friendly. If you're considering renovations or additions, they've got a wealth of resources to guide you through the process. Get start-to-finish support from a certified HERS rater to help you optimize design, select efficient technologies, and access incentives for your renovation or addition. Here's the scoop. Whether you're updating your insulation, upgrading and electrifying your heating, cooling, and hot water systems, or sealing your ducts, Mass Save has got you covered. Their comprehensive programs offer incentives and rebates that can significantly reduce the cost of those upgrades. And let's not forget, these improvements can help you save on your energy bills over the long term. Mass Save makes it easy to get started with their simple application process and their preliminary home visit. You'll get a comprehensive energy report on your home, plus they offer expert advice and resources to help you make informed decisions about your project. With their support, you can transform your home into an energy-efficient haven while enjoying substantial savings. Ready to start your renovation journey? Head over to Mass Save's website to review the process and explore all their programs and services specifically designed for renovations and additions. Head over to the Mass Save website at masssave.com, MASSSAVE.com, to learn more. That's it for today's Mass Save Minutes. Thanks for joining us. Remember, don't start that renovation process without checking out what Mass Save can offer you. Until next time, stay informed and energy conscious.
So the embodied carbon will not change no matter what of this spray foam, even if it like saves a person or a homeowner money. But the embodied carbon that's used to make, transport, and then potentially remove and destroy it later is very, very high.
Definitely. And actually, that's a great point. Removing and reinstalling. That's kind of, for me, what drives your choice of what insulation material you want to use for specific conditions. If you want to try and totally move away from foam, I think it's very admirable. But if you have one of those tricky spots where you're worried about condensation, you need high R value, you really want to think about the lifetime of the building. If you do end up having a problem 5, 10, 20, 30 years down the road, and you have to rip out what you've installed there and put in new stuff, that has another carbon impact. So you're kind of doubling what your intention was there. So if you can control for that situation and use a foam product, yes, it may have a higher embodied carbon count, but you won't have to ideally rip it out later and then do some remediative work, which has another carbon cost to it.
That makes me curious. So we, in our last episode, spoke to Wen and Paul, and Wen was talking a lot about insulation in the Boston area. Is there anything, like you said, there's certified installers? Are there certified removers yet, or anybody that like knows how to do this safely?
That's a great question. I think removing spray foam is not very easy because it expands into crevices. It doesn't really kind of peel off like you would imagine other products might. So I'm sure there are certified removers, just as there are certified professionals who remediate a lot of situations. It would really depend on the situation. I think in many cases, as long as your foam is not causing damage in tertiary ways to your other building components, then it's probably fine to just leave it there.
What about the potential fire hazard compared to other insulating materials?
Definitely. Yeah. So in terms of fire hazards, always use an expert. Fire is essentially what began building codes. And so people are very cognizant of fire in all kind of construction projects, all building applications in terms of testing product. Spray foam can be treated with flame retardants to reduce flammability, but materials and assemblies are tested and fire rated depending on how they stack and interact and where they are in the building. How the foam is mixed can play into flammability potentially, and how the foam is installed and allowed to cure. So foam is installed in what they call lifts, just to get a little technical for a second. And that lift is essentially spraying one layer, allowing it to cure, and then spraying another layer on top. So there are concerns with the curing process if you were to go ahead and spray, say, 12 inches all at once. That chemical reaction releases a lot of energy as it's curing, and it needs to dissipate that energy. So if it's too thick, then it may cause a problem. Yeah.
Interesting.
Always use an expert.
Yeah, it sounds like it.
I think you mentioned this to me, Kevin, when we were chatting earlier about this, but was this the issue with the Grenfell fires, the big fire in London?
The towers.
The towers, yeah.
So I'm not sure about the specifics of that case. Yeah, but we can just chat about it generally. I think that may have been an exterior foam application, and I'm not sure. So just kind of going on a tangent about how they test these things. There's a whole fire testing authority where you can, say, put together a building component, a little miniature model, not so miniature, kind of like the size of this wall. And it has your drywall, it has your framing, it has your insulation. They'll put it in a chamber and light it on fire and see how the flame spreads, if it spreads at all, what ignites, how long it takes it to ignite. And so in a lot of situations, from what I understand, there were exterior foam products installed on buildings that weren't maybe tested to that degree, or perhaps like a fire got so intense, it's so hot that it didn't really matter anymore. We know pretty much anything can burn, right? But these are petrochemical products, so they are inherently more flammable than something like, steel. So I think in that situation, fire spread up the foam exterior sheathing. So that was what the problem was. Yeah.
So as opposed to some of the other materials you mentioned today, though, bone and cellulose, fiberglass, this is more flammable in general?
I would defer to the experts on that. Yeah, certainly. So fiberglass is a spun glass. It shouldn't combust. Same with mineral wool. That's a spun rock product, essentially. So that shouldn't combust. Cellulose is recycled newspaper. It will combust, although it's not super sensitive to that. It's treated with fire retardants as well.
Interesting.
Okay, I have some questions specific to my house. I got quotes for insulation before we realized there was an oven tube. The first area was the attic, which we used for storage. And so the recommendation was to put it on the eaves. Now, when you're in the attic where there's not holes, you can poke the shingles. Like it's a shingle.
There's no roof sheathing.
There's no roof sheathing.
Sure.
So their recommendation was to put closed cell foam on it. And I was like, but that's like the roof.
Right. I think given the fact that we're trying to create solutions in existing housing where we can't really design around a lot of the conditions that are inherent to the building and also the environment that we put them in, we still want to insulate along the attic floor and maybe build up a platform for storage rather than kind of interfere with a lot of the convective nature of an attic that's essentially outdoors already. If you can see daylight up there, then it means there's a lot of drying going on. It kind of changes with the seasons. If you were to block off that daylight and really seal it up, you would need to really strategize for that, incorporate ventilation, think about how these materials are going to dry out if you encapsulate them in foam. It would be much more of a process.
Okay. So that was an interesting one.
Yeah, I was
very skeptical, and I was just like, I'm not.
It's going to cause you pause there. Yeah.
Yeah.
Yep.
But it's weird because it's like if I didn't work here, I wouldn't have known.
Yeah, we really got to do our research for anything we do in our homes. We're kind of on our own in that regard. We can seek recommendations from contractors and folks who say they've done it before, but we really need to do our own legwork on the back end, talk to people, check references, that sort of thing.
Okay, here's a second spot.
Yeah.
We have a 200-year-old single-family home with a fieldstone basement,
Mm-hmm.
and it's damp
Yeah.
because it's an old New England house. So the recommendation there by the same company was to put closed cell like just over the wall of the basement.
Mm-hmm.
And I was like, but water comes in through some of the cracks. And I was like, so what will happen to that water? And they said, well, it'll just run down the back.
You have great intuition, and this is your suspicion, like doing
Yeah.
doing great things for you. So I love this. Yeah. So I think when it comes to basements in existing homes, especially old homes, my house is 100 years old, so I totally empathize with your situation there. We need to be very cognizant of moisture control and water control. If you have a fieldstone foundation, there's very few ways you can make it totally dry in your basement without excavating around the exterior, putting in a French drain, doing a lot of things. There's no simple solutions. And I think some folks have had success with spray foaming on the inside of their foundation fieldstone walls, but it may be due to a little bit of luck, a little bit of kind of conditions that are unique to where they are. You can spray foam foundation walls as long as you account for that water and that drainage. So we often recommend using foam in foundation situations as long as you have a drainage plane behind it and an air gap, and then accounting for what is going to happen with that drainage. So that's usually kind of putting in a tile drain beneath it and then figuring out where it's going to go, whether through a sump pump or running to daylight, something like that. And Building Science Corporation did some great testing where they looked at the impact of insulation in assemblies where you have that air gap, because I think folks were concerned that, if you have a layer of air, isn't that defeating the point of insulating, right? And they found that you can have a pretty significant gap, maybe a quarter inch or eighth inch, and the impact to the insulating value of the assembly is pretty minimal. So controlling for moisture and allowing it to drain out through that kind of drainage plane can still provide like a good insulating impact to your basement.
But you wouldn't just stick it on the wall.
I personally would not.
Yeah.
Especially if you are seeing water come into the basement.
I have a follow-up question to this. All right. So say it wasn't a fieldstone foundation, it was a, standard foundation, and you could do this. You could spray foam it and insulate it. You were just talking about radon. Would that, if the home had radon coming in through the basement, would that make it worse or keep it in the house more or anything like that?
It could, yeah. So that's kind of the dynamics that we need to be cognizant of as we seal up our homes. Our existing housing stock, by and large, is very leaky, and that does a couple things. It allows for high air exchanges of fresh air, not really intentionally, right? It's just that when we built these homes, we didn't have the products we have now that we can seal them up with. We did our best.
So polyurethane.
Yeah, no foams back then. Horsehair plaster, we know that's very common. Yeah, that's my house too. And so we tried to make homes airtight. We just didn't have these products we have now. So they weren't presented with the challenges that we're seeing now with moisture control. Air quality was not a thing they were necessarily cognizant of way back then, other than controlling for combustion through chimneys and stuff like that. And so as we seal up these old homes, we need to be aware of how moisture behaves and how we provide more fresh air for a building. Radon's a great example in a lot of new construction. If you're in a area that is susceptible to radon, it's required by code to install a radon system. So if we're sealing up an existing home and you're in a high risk radon area, you should definitely test, and you should be aware of providing more fresh air for your building or finding a way to evacuate existing radon that you have down there.
Is that why a lot of New England homes have whole home box fans?
Oh yeah, that's a great one. That's a hot topic in the building world, is the whole house fan. That was kind of to steal that nice cold air from your basement, bring it up through the house. But you're exactly right in thinking about that while we're talking about radon. If you're bringing up a lot of those bad contaminants from your basement, contaminants like potentially radon, but also that's where classically your combustion fuel equipment was. So you're bringing up, imagine your hot water tank. Your classic atmospheric combustion hot water tank running while you have a whole house fan going. You're pulling up that burning air through the rest of your house, potentially causing it to backdraft as well. So those fans have a big fan club, pardon the pun, but you need to be careful of them. And I think, at least in my house, when I've tried to utilize the cool basement air for some passive cooling in the summer, it definitely has a smell to it.
Yeah.
Yeah.
Okay, situation number 3.
Yeah.
So there was an extension put on the house of a kitchen, and the part of the kitchen that you walk on is over the basement, but the part of the kitchen that like they built the cabinets and the counter on is just like over some air.
Mm.
And so underneath that, someone had put fiberglass at some point, but it's like old and not really insulating anymore. And there's no like air barrier, so it's very cold.
Mm-hmm.
And the sink is also there, so we had the pipe freeze. It didn't burst, but it froze because there was no insulation. So what was suggested was just put closed cell on that, but then it would be just closed cell exposed to like the air of the outside world,
Mm-hmm.
which I just thought was kind of strange.
Sure.
Is that strange?
I wouldn't say it's strange. I understand the suspicion. I think that would be actually a great application for spray foam. These kind of hangover floor / ceiling situations where you need to pack more R value and also be concerned about moisture drive. The one thing to keep in mind for that is you would likely want to essentially pack around that drain or the pipes with that closed cell spray foam. If you ever did have a problem, the only way to fix it is by ripping out the foam.
Okay.
But as long as you don't anticipate problems, then that's a great way to insulate it. Other ways would be to maybe pack it full of a dense pack cellulose or something similar. Dense pack fiberglass is probably better because of the sensitivity to moisture in that area being beneath your kitchen appliances and your sink, and then putting some other kind of material at the bottom of the joist, like a plywood or something like that, pressure treated.
Yeah, interesting. Okay, so the kitchen situation, maybe a positive.
Yeah.
And then maybe the basement, but not straight on the fieldstone.
Yeah.
Interesting. This answers a lot of my questions.
Good. That's great.
Cool. I'm very excited now. I'm going to go look at these spaces again with fresh eyes.
Yeah. And I think when you're debating between materials that you want to use for insulating, you want to think about how these materials behave when it comes to moisture and water. They all have their own applications in terms of their insulating properties, and that's great. But what we're very concerned about these days as homes get more airtight is where moisture goes. So when you think about something like cellulose insulation, it's a recycled newspaper. Newspapers can get wet and they can stay wet, but they can also dry out. Think about when you're reading a book, not a Kindle, paperback, and you drop a water droplet on it. That water is not going to stay in the area that it dropped. It's going to spread out, but it's going to dry out and you can still use that book. Conversely, think about taking your Tupperware out of the dishwasher and it's still wet. If you put the lid on that and put it in your cabinet, that water is still going to be there when you go to use it, however, a few days down the road, a week down the road. And so our foam insulation is very similar in that way. You need to essentially assist it with how it's going to dry out that water, whereas cellulose can kind of shoulder some of that load and disperse it much more easily.
That ties back to the concerns that they had in the UK with the spray foam, right?
Mm-hmm.
Interesting.
Yeah.
Interesting. I still feel somewhat suspicious, but not nearly as much so as I felt before.
That's good.
Yeah.
Based on some of the recommendations, I would share some of your suspicions.
Yeah.
You know, we have to be cognizant in these old homes that there's only so much we can do before we put ourselves in bad situations. So we want to do a lot. You know, the storage thing is certainly something we all want, but you got to maybe find some kind of compromise sometimes or spend a little bit more money to do essentially some like more robust construction work to kind of make it all function properly.
Yeah. Yeah.
It's kind of the same answer as Kristen's episode. If you want something that is healthy and done right, you really have to research constantly about what you're purchasing and what you're using and who you're using to install it.
Absolutely. Yeah. Because most importantly, we want to think about the lifetime of the building and the lifetime of the people using the building and not causing any side effects from the things that we're doing to the building or inside the building.
Any other deep thoughts about spray foam?
Oof. Deep thoughts. I guess we talked about wet basements and mold. That was all kind of related.
Can mold grow directly on that surface?
So
because it's not porous, right?
So open cell is more porous.
Okay.
Mold needs moisture, the right temperature range, and organic material to eat. So it needs like those three things. But you can have organic material settle on open cell foam that can create kind of like a food for it, just from like dust or something like that over time.
Okay.
Yeah. Yeah. I'm actually very much a try to use something else other than foam first, but a strong proponent of using foam where it needs to be used because of that aspect of thinking about the life of the building and not taking unnecessary risks in certain scenarios. But it's definitely by no means a silver bullet solution to all of your insulation and moisture needs. It can be far from that.
Yeah.
Yeah.
You must think about it pretty frequently, though, if you're working on buildings that are being constructed now that are going to last 100 years. And we're thinking about also the changing climate and the humidity probably increasing up here. Wow.
I wouldn't say it keeps me up at night, but yeah, it keeps me up at night sometimes. Yeah.
Are the new like multifamily buildings having spray foam in the walls, or is it used only in those specific circumstances?
More in retrofits because of kind of these unique scenarios where you're given a problem to solve that you weren't allowed to develop the framework to, and you have to do that thing where we said squeeze a lot of R value maybe into a small space. But new construction generally, you are using foam board a lot of the time, or you're using a mineral wool board or a wood fiber board. And then in cavities, you're often using a batt insulation or a blown-in insulation like a cellulose or fiberglass.
Okay.
There are a lot of ways you can do it, but oftentimes cost is the driver. Foam is more expensive than these other materials.
Yeah, and if it's a really large building, that
It's
is
a large building. You have big
factor.
cavities. You can fill them with a lot of material. And then what we know is a great solution now is continuous insulation on the exterior. That does a great job of mitigating thermal bridging effects, and you don't need much to do that. So in a combination with your cavity insulation and your continuous insulation, you can put together a really well high performing wall assembly without needing foam for the most part.
Nice. That's interesting.
Mm-hmm. I want to hear more foam suspicion because I'm here for it.
I mean, those are my main three from my own experience, but
How long ago did they quote you on that?
it's like 2021.
The other thing is things are changing fast. We're learning more. Sometimes it feels like by the month, certainly by the year. We know a lot more about foam than we knew 5 years ago, certainly 10 years ago. And a lot of it's been through trial and error. A lot of times we will see legacy spray foam installation projects where the mixture wasn't great. And it isn't necessarily a mold concern or a fire concern, but from a performance aspect, we've seen situations where it's pulling away and kind of contracting
Oh, interesting.
to the degree that in some situations we've seen it pulling apart framing
Wow.
because it had that kind of grip on it.
Yeah.
And so that's obviously a huge problem.
Yeah. How
But
quickly does that kind of issue show up? Like it was like 5 years old, 10 years old?
I think that's probably a good
Yeah.
range. Yeah. That's an extreme scenario, but
Yeah.
that's what, getting these mixtures right really means. Sometimes it won't adhere properly. I mean, and again, that kind of comes down to making sure that people installing are certified and know what they're doing. They've done it before.
Yeah.
Because you can go to a store now and buy a 2-part spray foam solution and go into your house and go crazy.
And you really?
Yeah.
So will that be an issue though, of like this unmortgageable concept of like they won't know whether you had a certified installer or whether you just went to Home Depot and bought it?
It's a great point. And I think it does come down to messaging. So the most worrying aspect of that article to me was not necessarily that people were using foam or the inherent characteristics of foam and what it can do, but that folks felt very emboldened to go and do these foam projects without maybe enough research. But again, we do a lot of things to our homes that maybe mortgage companies aren't aware of and buyers aren't aware of. So there's a lot of degrees of risk to that. So I think that may be one reason, speaking to the article, why they put kind of a blanket concern over all foam, because they want to step back and evaluate what's going on first. We have great tools for air sealing and insulating right now. It comes down to reducing the cracks and penetrations in your home as best you can, but just by filling them with materials, building materials, sealing them with things like caulking, mastic, and then insulating with things like fiberglass, cellulose, wood fiber, and controlling for that vapor drive and that moisture drive. So we have a lot of tools at our disposal. It's just a matter of knowing how and when to use them, and also using foam in some of these trickier situations and being aware of the dynamics at play when you're using it.
Any closing thoughts before we head out to lunch today, Kevin?
I think we just about covered everything. Just be cognizant of the conditions that you're trying to insulate, and do your research, and always hire an expert.
Yeah. Thanks for that. Thanks for easing my fears.
Anytime, hopefully.
We'll talk to you again soon.
All right. Thanks, everyone.
Thanks,
Bye.
Kevin.
Thanks so much, Kevin, for chatting with us today and for all that insight into spray foam insulation. We encourage all of our listeners to check out our previous episodes and like, rate, and follow Building Well on your preferred player. Stay up to date for future developments and episodes on Spotify, Apple, Amazon, YouTube, Pandora, and most other podcast services. Information on this episode, including show notes, references, and the transcript, can be found on our website at newecology.org/buildingwell/podcast. Please follow New Ecology on LinkedIn, Instagram, and Twitter at New Ecology. And thank you to all of our listeners for tuning in today. See you on the next episode. The Building Well Season 1 podcast committee at New Ecology is led and organized by Alina Michaelevich and Michelle Moran, with Molly Kraft and Michael Abdelmessi. Production, editing, and music by Michelle Moran. Episode description by Kevin Collins.
This episode was made possible by the Mass Save Community Education Grant.